Thanks for the lovely chat. 11.7 is areas and volumes. So still things we've been talking about, like surface area, lateral area, volume, right? But now of similar figures. What are similar figures?
They look almost the same.
Proportional. That's the word I want. They are proportional figures, okay? So here's the lovely thing. You don't need to know all the dimensions anymore of a figure. If you know the volume of this figure and you know they're proportional, you can use that relationship to find the volume of the other one without having to do all the formulas. It's kind of nice. So that's what we're going to do today. Similar solids are solids that have the same shape and corresponding dimensions that are proportional, as Cole told us. Okay, that means if they're proportional, we have a scale factor. Remember scale factors?
Yes.
Yeah, we've done this. So one thing to note, cubes are always proportional to all other cubes, right? Rectangular prisms are not always proportional to every other rectangular prism, but a cube is always like 3 by 3 by 3 and then 4 by 4 by 4. So their scale factor is 3 to 4 and 3 to 4 and 3 to 4, right? So that scale factor is never going to change because all the sides are the same lengths on both of them. Same thing with circles. The relationship between circles all relies on that radius. So if this circle has a radius of 2 and this circle has a radius of 3 and this circle has a radius of 4, then 2 to 3 is the scale factor of these two. 2 to 4 is the scale factor of the other two, right? So circles, no matter what circles they are, will always be proportional to every other circle. Sphere, sorry, I'm saying circles. Sphere. It works with circles too. Did you have your hand up?
So we've learned this because this looks very familiar.
You have learned most of this.
Oh, okay.
Yes, you've done a lot with this information. Now we're going to take it to the next level with three-dimensional figures and how they apply to that. But yes, this should be very familiar to you, okay? All right, so here's the deal. The question is, are the figures similar? If so, you're going to give a scale factor. Remember, scale factor is just when we talk about dimensions, okay? The length, the width, the height, those are our dimensions. So your scale factor is going to come from those lengths. Okay, so let's figure, are these figures similar? So if I look here at, I'm going to just highlight in different colors. This 3, we would say relates to what side on the other figure?
6.
The 6, okay? This 3 here corresponds to this 6, and the 2 corresponds to the 4, right? So what we're saying is the scale factor is 3 to 6. Oh, and we changed colors, my bad. And then we have another 3 to 6, and then we have 2 to 4, okay? Now, if all of those are truly equal, our figures are proportional, okay? These are similar figures. So 3 to 6 is 1 to 2, 3 to 6 is 1 to 2, and 2 to 4 is 1 to 2. So because they are all the same scale factor, we would say, yes, these figures are similar with a scale factor of 1 to 2. Does that make sense?
Yes.
Okay, so now look at your next two figures. You have 2 by 3 by 2, and then 3 by 6 by 3. What does this 2 correspond to?
3.
The 3 over here. Okay, what does this 3 correspond to?
6.
The 6. And what does this 2 correspond to? The 3. So if you set up your ratios here, we're saying 2 to 3 would have to equal 3 to 6, which would have to equal 2 to 3. Are those figures similar?
No.
No, because this one is 1 to 2, right? These are not equal. So if any of them are not equal, then we would say these are not similar. Okay, they all have to be proportional. Questions on that?
Miss Ruben,
Yeah.
have you ever met a famous mathematician?
No. I mean, Mr. Bexford. He's my famous mathematician. He's not famous, but he should be.
Albert Einstein,
I mean-
Euler, Euler.
Uh, no. There's still very like brilliant math minds that are
Is there like geometons?
well known. Anyway, you keep getting distracted. Focus today. Stick with it. Scale factor, surface area, and volume ratios. Okay, this part should be very simple for you because you've done this before, just not with the volume part of it. Okay? A scale factor is basically taking
Simplifying numbers.
I was just looking at my notes, look funny there. A scale factor is taking the dimensions. So whenever we're talking about the dimensions, it's 2 by 3 by 4, right? That's your scale factor, okay? Your surface area is going to take the surface area of one figure and compare it to the surface area of another figure. Your volume ratio is going to take the volume of one figure and compare it to the volume of another. So here's how it works. If we know a side length, okay, of each figure. So let's say I know one figure has a side length of 1 and the other figure has a side length of 2. My dimensions mean our scale factor is 1 to 2, okay? When it's an area ratio, we're just squaring those numbers. So what would the surface area ratio be if the scale factor is 1 to 2?
1/4.
1 to 4, right? It's 1 squared to 2 squared, which is 1 to 4. Okay, so with a scale factor of 1 to 2, we'd have a surface area of 1 to 4. Your volume cubes the scale factor, okay? It doesn't cube the surface area. You don't cube the one right before it. You're cubing A, right? So you're cubing and you're cubing. So what would your volume ratio be if your scale factor is 1 to 2?
1/8.
1 to 8. You're going 1 cubed over 2 cubed is 1 to 8. Okay? Okay, so with that in mind, there's this definite relationship here, right? With that in mind, London, put it away. What would you do if they tell you the volume ratio? Okay, so they're telling us what the volume ratio is. They're telling us this one. How do I get back to the scale factor then?
Square root 3.
Which is called a what?
3 square rooted.
No, it's not a square root. What is it when it's a 3? It's a cube root, right? So here's what you're going to do. You're going to plug into your calculator the cube root of 3,375 and the cube root of 1,728. I would not divide them right now. I would just plug them in separately. The cube root of 3,375 is 15. The cube root of 1,728 is 12. And I would plug those in right now to make sure you've got it, okay? Because a lot of the times it's not the knowing what to do, it's actually doing it that gives people the trouble. Remember, you do 3, and then you do the second key, and then you do the caret, and then you type in whatever number you're taking the cube root of. Okay, so plug that in real quick. Cube root of 3375 is 15. Cube root of 1728 is 12. What's your scale factor?
5/4.
You got to simplify it. 15 over 12 is going to reduce to 5 to 4. So our scale factor is 5 to 4. Okay, so if they give you volume, you're going to cube root it. What if they gave you surface area? So what if they told you your surface area ratio is 9 to 16? Then what's your scale factor?
9/16.
Yeah, you got to square root it then, right? It would be the square root of 9 and the square root of 16, so 3 to 4. Okay, so you're kind of thinking backwards on a lot of these. And just remember, area is squared, volume is cubed. Okay? Okay, 2 more problems and then we're done. So this one says, the volumes of two similar solids are 40 cubic inches and 135 cubic inches. Okay, so right there, you should say, oh, I know my volume ratio. What's my volume ratio?
48.
40 to 135, right? That's the ratio of my volumes, 40 over 135. Now, is 40 over 135 reducible?
Yes, it is.
Mm-hmm. You always want to reduce if you can reduce, okay? So 40 and 135, we can divide by 5. So that's going to be 8, over 27. Okay? So my volume ratio is 8 to 27. It says if the surface area of the smaller figure is 48 square inches, what's the surface area of the larger figure? Okay, now this is the problem that is probably the most difficult, because not because of what it is, but because of how many pieces it takes to get to your final answer. People always try to skip a step, and it's this next step that they try to skip, okay? I know my volume ratio. I'm not looking for a volume. What am I looking for? Surface area. So if I'm at volume, okay, let's go up here. I'm at volume, and I want to get to surface area. Where do I have to go first?
Cube root it by 3.
You have to cube root it to get to scale factor, and then what are you going to do to get to surface area?
Square.
Then you'll square it, okay? So here's what we have to do. The cube root of 8 over the cube root of 27 is going to be our scale factor. Cube root of 8 is 2. Cube root of 27 is 3. So my scale factor is 2 to 3. I don't want a scale factor. What do I want?
A surface area.
A surface area ratio. So what do I have to do to 2 to 3? You got to square it. So surface area is going to be 2 squared to 3 squared, or 4 to 9. Okay, that's where we want to be. We want the surface area ratio. But you see, it's a 3-step process to get there, right? So take your time, do it right. Now look at the information they gave us. It says, if the surface area of the smaller figure is 48 square inches, what's the surface area of the larger? So at this point, now we're going to set up a proportion. So we're going to say 4 over 9. Where is the 48 going to go? Top or bottom?
So top.
On top. It's the smaller figure. This one's smaller, so across from the smaller is our smaller. The one we're trying to find is going to be x. And now all you do is cross multiply. So we're going to go 4 times x equals 9 times 48, which is 432. Thank you. So divide by 4, and we get x equals 108. 108 what?
Inches squared.
Area.
But even though you use cube, would it be want it to be 3?
No, because it's the surface. Volume is not used to.
Because it's an area that we just found,
Oh, okay.
right? We wanted to find the other surface area, so it's square inches. Does that make sense? Sorry, I didn't give you a lot of room there, did I? My bad. Okay, last one. Let's see if you can talk me through this, okay? Look at all the words, all the details, see if you can figure out what we know and what we're trying to find here. It says Office Max sells paper clips in small and large boxes. A small box holds 220 paper clips. The large box is formed by doubling the dimensions of the small box. How many paper clips should fit in the large box? Tell me what you hear, what you see, what you know that would help us in this problem.
220 paper clips.
220 paper clips represents what right now?
The small one.
What about the small box?
The surface area.
The volume. Who said that? Someone said it. Volume, right? 220 is a volume because it's how many fit inside the box, right? The space inside the box is our volume. So we know one of our volumes is 220, okay? We want to know how many paper clips in the large box. So the volume of the small, we're looking for the volume of the large, right? That's what we want to find. What else do we know?
It's 1/2 for the surface area because like a small box is the one and then you double it for the bottom would be 2.
But we doubled the dimensions, right? So it's basically saying if this is our small box, you don't have to draw this picture, but I'm just going to draw it to give you a visual here, right? So if this was 1 inch tall, now it's going to be how tall?
Double.
Now it's double. If this is 2 inches wide, how wide is it here? 4. If it's 3 inches long, now it's 6, right? So we just doubled the dimensions. What is this relationship? Is that a scale factor, an area, or a volume? That's a scale factor, okay? So when they say they doubled dimensions, that means our scale factor is 1 to 2, right? What was 1 became twice as much.
But then you have to find volumes to the cube.
Right. So now you're going to take that and you're going to turn it into a volume ratio. So what is our volume ratio?
220 over x equals, or 1 over times 1/8.
Equals 1/8, right? So you cube this, 1 cubed over 2 cubed. So my volume ratio is 1/8. And I know the volume of one of them, and I can find the volume of the other one by setting up a proportion. So lots of proportions today, okay? So we're going to say 1/8. Where does the 220 go? Top or bottom?
Top.
On top. It's the smaller, so go across from the smaller number. X on bottom, cross multiply. So X is 8 times 220, which is 1,760
Paper
what?
clips
Paper clips.
in larger box.
Okay? Does that make sense?
You know what would be fun?
Does this have anything to do with this right now?
Yes, it is.
Really?
Yes. What if there are another